So yesterday we talked about how the unit circle is related to your graphs of sine and cosine. I also told you that we focus on these certain points because there are certain points that are really nice and easy to graph versus some of those points that have the square roots in them, right? Like root 2 over 2, root 3 over 2. Okay, those aren't going to be as nice to graph. So we're going to focus on the 0, pi over 2, pi, 3 pi over 2, and 2 pi. So whenever you are doing the sine, you are going to use this pattern. So we're going to go over the useful patterns and points. Okay, so we're going to do the f of x equals the sine of x. And when we do this, we're going to be using a table. Okay, so in your table, you have your input x, you have your output f of x. When you are starting your table, you are always going to start at 0. Okay, so we're always going to start at 0 for the x. Now, where we end, we are always going to end at the period of the function. Okay, so the period for sine, what we talked about yesterday, is that the period for sine is 2 pi. In between is going to be the halfway point. So halfway between 0 and 2 pi is pi. And then really you're just finding halfway between these two. So halfway between 0 and pi is half of it, so pi over 2. And really that's what you're counting by, is pi over 2. So we're going 1 pi over 2, 2 pi over 2. The next blank would be 3 pi over 2, and then 4 pi over 2 reduces to 2 pi. So yesterday, we looked at this graph of sine. So if we look at what's happening at 0, we can see this point here. Okay, at 0, we are at 0, which means this is an x-intercept. Now, wherever the graph starts, it is also going to end. Okay, so if we end here, okay, if we start at 0, we are going to end at 0. Now, with sine, where else are we going to have a 0? At what value? Pi, great. So we can see that on our graph, right? So 0, pi, and 2 pi. So halfway in between is going to be an x-intercept. Okay, now halfway between these first two x-intercepts, okay, we can see it reaches what value? Yep, 1, which is the maximum. So at 1, we're going to reach the max. In between the next two, we're going to go to the minimum, which is -1. And that is the pattern that we're going to follow. So once you've established that pattern, you just continue the pattern to span the grid. All right, so we're going to do just a quick little graph of this. Okay, so you have your output and your input. So try to make those so that they're a consistent amount apart. Okay, and then we're going to graph that together. Okay, so the way that I graph them, it is in an intentional order, and you will be following that pattern the same way. So wherever you start, it's going to be 0. And then wherever you end should be the same as where you started. So we started at 0, we end at 0, halfway is 0. So we go 1, 2, 3. The fourth point we graph is the max, then the min, And then remember, we connect these with a curve. Okay, so those do need to be curved. Okay, and then we put the arrow. This is going to continue. This is going to continue. And that is your graph of sine. Okay, now we're going to talk about the graph of cosine, which is a little bit different. So sine and cosine, if you were to translate this graph over, okay, they would line up perfectly. We'll call this one g of x. Okay, so g of x is equal to the cosine, so we're going to have x, and we're going to have g of x. Okay, so just like with sine, you're always starting at 0, and you're always ending at the period. Okay, and for the parent function, the period is 2 pi. Okay, so your halfway point, pi, half of that, 1/2. Are you with me? Okay, and then we're going to talk about the pattern here. So for sine, it's x-intercept, 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 then you do the max, then you do the min. Let's look at the graph of cosine. So at 0, where are you at with the cosine graph? You're at the maximum value there. Okay, so you have the max at 1. So remember, wherever you start, that's where you end. So if you start at the max, you end at the max. Okay, so we can see that on our graph. You start at the max, you end at the max. Halfway in between, you're where? The min. So you're at -1, which is your minimum. And then halfway in between those, you're where? 0. So you're at your x-intercepts. Okay, so we're going to follow that pattern. Okay, and that's how we are going to graph the cosine. Okay, so they are going to have different shapes. With the sine, I think of it as the up wave and then the down part of the wave. Okay, with the cosine, I think of it as like a ram's head. I wrote it on the board. I think of it like that because my zodiac sign is a ram. Yeah. Are any of you Aries? You're not March? Are you March birthday? Oh, when my March birthday? Early April? All right. Yeah. That fire sign, that ram. You'll see once we graph it. Okay, so when you are graphing this, you are starting at 0, 1. Okay, and then you're ending at 2 pi 1. And then halfway you're at -1. And then halfway in between you're here. This is not a V shape. You need to connect it with a curve. So if you're having trouble with that, remember what I said yesterday? You can connect these 3 points with a curve. And then be careful when you go here. I noticed yesterday a few people were putting the arrows up. That's not going to go up because this is the maximum, right? That's the highest point. So when you connect this, you're connecting this part with a curve here. Okay, so you're connecting it, and then you're going to bring it back. Right, and then so you have that curve. So see how it kind of looks like a little ram's head? Just say yes. Yeah, Mrs. Whipple, we see what you mean here. Like right here, and a little horn, a little horn. Okay. All right, and then we're gonna take those parent functions and we're gonna perform transformations. Okay, so we're gonna do transformations. Okay, for the rest of this week. So we're gonna start with a few transformations and then we're gonna keep adding them on. Okay. So for today, we're going to think of this form. So if your y is equal to a sine of bx or a cosine of bx, remember that when you have something multiplied in front, this produces what's called a vertical stretch. If the a value is greater than 1, okay, that means it stretches the graph vertically, like up and down, you're pulling it apart. Or if it's a fraction that's between 0 and 1, and it's the absolute value of it, if it's between 0 and 1, then it compresses it vertically. Okay, I think of like a can being smashed, being flattened out. And when you have those, it is going to affect the amplitude. So we want to know what is going to affect our amplitude, what is going to affect the period of the function. Okay, and if you have a negative value for a, if a is negative, what that does is it creates a reflection across the x-axis. Okay, if there is a reflection, that is going to switch the max and the min, so we're going to write that down in a moment. Okay, the value of b indicates a horizontal stretch or compression, and what that does is it affects the period. So if you have a horizontal stretch, it pulls it apart from left to right, or it can compress it from both sides. Okay, and so that is going to change the period. Okay, so we're going to talk about the effects here in this little information box. So they give you the functions there. If a is not equal to 0 and x is in radians, the amplitude is the absolute value of a. Okay, so the amplitude is always positive. Okay, what that does is it affects the max and the min values. Okay, the period is 2 pi over b. Okay, and because it's dependent on b, we know that the b value affects the period. Okay, and then the last thing we want to notate is if you have a negative value, so if a is negative, the max and the min are going to switch. Bless you. Okay, so using our parent functions as a guide, we're going to graph the function, and then before we do that, we're going to identify the amplitude and the period. Okay, so I know, that's why I said that. All right, so amplitude and period. So the amplitude is just the absolute value of A. Okay, so Akul, what do we get for that?
1/2.
Great. Okay, so A is 1/2. Okay, that's your value here. Okay, and then to find the period, all we have to do is 2 pi over b. Let's see how that went. So when you're putting this into your formula, the period is 2 pi divided by 1/2. So if you do 2 pi divided by 1/2, what's that?
2 pi times 2 over 1.
2 pi times 2 over 1, which is 4 pi. Great. Right? Okay, so 2 pi divided by 1/2 is 2 pi times 2 over 1. Okay, so 2 pi times 2 is 4 pi. Great. Okay, so now we're ready to do the second step together. When you are graphing, there's certain things that you want to recognize. For your notes, we're going to write out what's happening for the first couple times. And then after you understand the patterns, you're just going to be able to write them out in the table. So what we talked about was the A value affects the max and the min values. So what we're going to write here is our A value. Okay, what it's doing to the graph is it's vertically compressing it by a half. It's a parenthesis. Like this is what's happening to your A value. Because I wanted to. Don't judge me. Right, so if it's a vertical compression, you can also just put an arrow. If it's a vertical compression by 1/2, we said that it affects the max and the min. And you guys looked at this yesterday in your packet. So when you had like a 2 out front, do you guys remember that the maximum became a 2? And the minimum became a -2? Okay, so what this is going to be, if it's 1/2, your max is going to be a 1/2, and your min is going to be -1/2. So it's going to be the A value and the opposite of that. Okay, and then the B value that is going to affect the period. So what's happening to the graph is it's a horizontal stretch by 2. The reason why it's a stretch by 2 and not by a 1/2 is because when you calculate this, do you see how we use the reciprocal? Okay, so that's what's happening is you're actually multiplying it by 2. That's what the horizontal stretch is. Okay, you aren't going to have to write this out every time. I just want you to be able to look at your graph and be like, oh yeah, it's being pulled apart horizontally. That matches what would happen. Okay, and then we said that this affects the period, which we saw. So if it affects the period, that means instead of ending at pi, now we're going to end at 4 pi. So we're going to end at 4 pi instead of 2 pi now. Okay? So we're going to set up this table together. So you are always going to have to create a table with your 5 points for your graph. So we're going to start with x and g of x. Okay, so Silas, where are we always going to start? What's our starting x value? 0. So we're going to start at 0. Okay, now we're going to end at the period, which we just said was what? 4 pi. Okay, so can you guys tell me what we're going to put here in the middle? Yeah, great. That's your halfway. And then you do halfway of the halfway. So what's halfway between 0 and 2 pi? Pi. Okay, so then you're counting by pi. So 1 pi, 2 pi, 3 pi, 4 pi, 1 fish, 2 fish, red fish, blue fish, yeah. Okay, so now we can do our pattern. If it is a sine function, at 0, where are you? Are you at 0 or the max? Those are your two options. You're at 0 for sine, you're at the max for cosine. So you do your x-intercept, okay, right here. And so your parent function. Okay, so at 0, we were at 0. So if we start at 0, we end at 0. Okay, and then for sine, your halfway is 0. So you're always doing this pattern. X-intercept, 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 and then halfway in between them is the what? The max. Yep, halfway in between the other two is the min. So our max is now 1/2. Our min is now -1/2. So we're using that pattern to graph. Okay, so you start at the x-intercept, you end at the x-intercept, midway's the x-intercept, max and min. Whenever we label our graphs, you are always going to label them underneath the x-axis. Okay, if we don't do that, I'm going to have you do it again because when you label it here, it's too hard to read, so we're going to label it below. Okay, and then when you do this, you are going to span the entire grid. Okay, so you have to just continue the pattern. So we're going to label the x-axis scale underneath. Okay, we are going to span the entire grid when we graph. All right, so if I want to go to 4 pi, you can always split it up into quarters. So you could go every one is pi, or you can do every other one. Like we could make this pi. We can make this 2 pi, 3 pi, and 4 pi. You could also do 1, 2, 3, 4. That would be fine. A good way to do the scale is to take your period and divide by 4. And I do like you to label like all of the, like every other one here, and then there you can just do a few is fine. Just like this.
Gotcha.
Okay, now when you graph, you're going to span the entire grid. So the first thing we're going to do is we are going to start at 0, 0. Okay, so if we start at 0, 0, I graph that first. The end is 4 pi. So I do the start and the end. The middle is 0. And then halfway in between, because it's a half, let's go ahead and scale the y by halves. So that would be 1/2. Sorry, and that would be 1. So then you're going to go up to 1/2, down to -1/2, and then remember, you're connecting these with a curve. And when I say span the grid, that means we're going to continue the pattern. So if you continue the pattern, see how you did the max here? The next thing you're going to have to do is the min. So it goes max, 1, 2, 0, 1, 2, min, 1, 2, 0, 1, 2, max, 1, 2, 0, 1, 2, min, 1, 2, 0. And it just keeps going like that over and over again. Okay, so you just need to span your given tree graph. Okay, and you can use a calculator if you want to check your work, but you will need to be in radian mode. I actually think it might be easier for you to check with Desmos, but you do have to set it up like so your scale is in radians. Okay, so if you want to check, you do have some tools to do that. Okay, and then we're going to graph our cosine next. So again, we're finding the amplitude and the period. So your amplitude is just always what is multiplied to the trig function. So in this case, your A is 1/3. Okay, and then we're going to calculate the period. So it's 2 pi over B. Bless you. Okay, so your B value is 2. So the B value is always multiplied by X. So once you reduce those, you're going to get pi. Okay, and then what we do is we think about how those are affecting the graph of cosine. So your A value is always going to change your graph vertically. And if it's a fraction, it's going to be vertically compressed by 1/3. Anytime you have something affecting it vertically, it's changing that max value and the min value. Okay, so if my amplitude is 1/3, what's my new max value? 1/3. What's my new min? Thank you. Okay, and then for your B value, that is going to be a horizontal compression.
How do you know it's compression?
So you take the reciprocal of this value. So if your B value is 2, the reciprocal is 1/2. And if it's a fraction, it's a compression, which basically means you're taking your graph and you're pushing it together. Okay, and then what that means for our table is now our graph, because it affects the period, okay, your graph, I'm going to say cycle, ends at pi. Okay, so when you're thinking of, okay, well, how am I using this in my table? You have x and you have h of x. And we know we're always starting at 0. We're ending at the period. So we start at 0, we end at pi. Okay, so we start at 0, we end at the period. Okay, what is the halfway? Pi over 2. What is half of pi over 2? Pi over 4. So can you guys tell me what this one's going to be? Okay, so if you go from 0 to pi over 4, you're counting by pi over 4s. So 1 pi over 4, 2 pi over 4, 3 pi over 4. Why did I write that? Okay, so 1 pi over 4, 2 pi over 4, 3 pi over 4. This is 4 pi over 4. Okay, so that is your 3 pi over 4. Now this is cosine. So at cosine, at 0, you are at the maximum. Great. And if you start at the max, you end at the max. Nice. Okay, so we set our max as 1/3. So we have 1/3, 1/3. Halfway in between is the minimum, which will be negative 1/3. And halfway between the halves, the zeros, the x-intercepts. Great. Okay, so when you guys go to label this, okay, you can label that however you want. If you label it singly, that's fine. Like if you did 1 pi over 4, this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, and then 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. What's 8 pi over 4? 2 pi. 8 over 4, right? Okay, and you don't have to label every single one of those. And then on the other side, I generally do every other one because you're just following the pattern. So it would be negative pi over 2, negative pi, 6 pi over 4 is negative 3 pi over 2, negative 2 pi. Okay, now because this is 1/3, let's just make it easy on ourselves and let's scale our y's by what? Yeah. So if I'm scaling by 1/3, it's 1/3, 2/3, 3/3. So the 1 is at the 3. Okay, so we're going to start at 0, we're at the max. Okay, at pi, we're at the max. Okay, so this is our start. If your period is pi, you're going to end here. Halfway in between, you're going to reach your min. Halfway in between those, you have the intercepts. Now, again, do not connect this with a V. That's not what it is. You have this shape here that you can do first. Okay, and then these are going to be curved as well. Ew, sorry. Okay, and then we're going to continue that pattern. So do you see here we do the min, the 0, the max. Okay, then you go back to the 0, the min, 0, max. 0, min, 0, max. So then you're just going to continue that pattern. Do not put your arrow going up here because that's incorrect. So back to 0, then to the min. 0, max, 0, min. 0, max, 0, min. And then we're connecting those through. Ooh, that looks good. How did your guys' turn out? Not ooh. Okay, so remember how there's a horizontal compression? So like when you're compressing it together, you'll get more waves if you use the same scale. Okay, but you can kind of manipulate your scale so that you can graph it easier. All right, now the last one we're going to do is going to be a little different. So we have f of x equals -2 sine of x. Okay, so you're always finding your amplitude and your period first. Okay, so your amplitude, remember, is the absolute value. So the absolute value of -2 is 2. Okay, so this is your amplitude. Okay, when you're doing this on your own, this is what you're going to be doing first. You're going to find your amplitude, and then you're going to tell yourself, okay, if that's my amplitude, what's my max? What's my min? Max is 2, min is -2. Now, what makes this one different is you have this -2 in front. Do you guys remember what that does? Yep, it changes flips the what? Where the min and the max occur. So when there's a reflection, because you have that negative in front, so the reflection is related to that, okay, it just flips the order of the max and min. Okay, so we'll alter that part together, okay? And then we have to do the period. So the period is 2 pi over b. What's our b value here? 1. So 2 pi divided by 1 is just going to be 2 pi. Okay, so we're going to make our table. So we have x and f of x. So when you're doing this on your own, you can do it like part C. Okay, you don't have to write out that there's a reflection and that there's a vertical stretch. But again, those are just going to help you see if you did your graph right. Okay. So we're always starting at 0. We're always ending at the period. Okay, so we start at 0, we end at the period. Halfway is pi. Half of pi is pi over 2. And then we have 3 pi over 2. This is our standard scale whenever you have 2 pi. So this is the sine. So at 0, we're at that x-intercept. We're at 0. And if we start at 0, we end at 0. Halfway, 0. That's what it is for sine. Now, normally, halfway in between the first two, that's when we have our max. But because of that reflection, it's now a min. So this is where the flip takes place. Where there was a max, there's now a min. Where there was a min, there's now a max. You saw that on your packet when you had a negative that you had to multiply by. So this is -2, and then this is 2. Okay, now just to keep this so that it looks similar to what we did before, I am going to scale my y's by 1/2. And I'm only doing that so that you can really see the difference between something that has the 2 in front and a fraction. Okay, so if I keep this by the 1/2, this is where my 2 is. This would be where my -2 is. And then the x's, you're always labeling those underneath. Okay, so you have the pi over 2, the pi, the 3 pi over 2, the 2 pi. Again, if you wanted to label those every one, you have the option to do that as well. It is kind of nice sometimes to spread those out. And then when you are graphing, you are going to start at 0, 0. Your end is 2 pi, which is 0. Okay, and if you ever couldn't figure out what was halfway, you can always count. There's 8 spaces in between. Halfway is 4. Okay, halfway between these two, we usually go to the max, but remember we flipped it to the min, and this one is flipped to the max. So we can really see that vertical stretch here if we make the, oops, got a little shaky at the end there. Okay, and then if you had a minimum, you don't go to a minimum again. It needs to be the same wave. So now these are 2 apart. So we're going to go 1, 2, max, 1, 2, 0. 1, 2, min, 1, 2, 0. Okay, and then we're connecting those with a curve. Okay, if you notice your hand is a little shaky, again, just do the parabolas. Okay, and then you are going to do the 11 for worksheet for your homework. So you guys, did some of you, you guys didn't skip the vocab question, did you? No, you just have to circle the correct answer. Okay, so you're going to do that worksheet. All of the graphs have to be on your graph paper. So the ones that are graphs are 4, 5, 6, 14, 15, 16, 17.